All right, on today's episode of Python Papi, we're back inside our TensorFlow course, and we did dive deeper into our malaria functional API module. Let's have a look at what we went over today. Now, yesterday, if you recall, we just went over some basic information, and we actually started writing some code. And today, we're actually going to look at and see exactly what we went over concerning the code. Let me see exactly where we left off at. I think it was, oh yeah, after the X's, okay. All right, so once we get to the end, we are going to create the Lynette model from this. From all of this information here, we're going to create our Lynette model. We're still using the Lynette model because we are still using images. And if you recall, the Lynette model is best geared towards images. So that's why we're still using that. So we have Lynette model equals model, which we'll import, and then we will pass in the funct input as a parameter. So this is the original version that we had here. You can see I have it commented out. You'll see why later. But we have the Lynette model equals model, which we imported, and then we pass as a parameter the funct input. Now let's say we have a func input and we have a func output. See lines 214. So you can see lines 214, we have a func output equals dents1, activation equals sigmoid, and line 214 was modified from 212. So this was the original, was x equals dents1, but we modified that to be a func output, meaning we wanted this to be the function output. So that's why we have that. We will modify our Lynette model to take as parameters the input and the output. We will also give it a name, which will be Lynette model. So you can see here, this was the original, like I said, that's why we have it commented out. This was the original, was the Lynette model equals model func input. And we modified it to take the input and the output and give it a name. So now we have the Lynette model equals model, func input, func output, and a name equals Lynette model. Now we created our Lynette model. And then from here, we could simply do Lynette model.summary, which we ran here. As you can see, I already have it geared up. So you can see here, we have a summary of all our information. It actually compiled because we didn't actually get to the part, this part compiled because we didn't compile the actual code. We're just compiling a summary. So that's why when I say compile, don't get confused with actually compiling and running a code. Now we'll notice that we should have exactly the same number or the same summary as we have with the sequential API. Now let's run it and see what we get. We have the same model information that we have from our sequential API. So basically what we've done here is we created this model, which we previously done with the sequential API. Now if we got this, let's see what we have to, we'll see that we don't have to change absolutely anything from our code. So now we're going to compile our model without changing anything. And we use the same Lynette model. So this is the part where it's actually going to take forever, actually compilation of it. So all of this stuff right here actually went through. As you can see, we compiled all of that successfully. Everything came through. We compiled our model. We got back our parameters. These are the 16 images, as you recall, from the sequential model. We went through the 16 images. Tell us that if the cell was parasitized or unparasitized. So we got through all of that. And this is just more summarization of the actual model. You can see our parameters here. We still have the same number of parameters. You remember it was 46 million and change. And then non-trainable was 2,244. So all of that stuff still went through good. It's this part right here, the history, it equals Lynette model.fit. When we actually try to compile our model, this is the part that's going to take actually long because you remember the CPU versus the GPU issue. So yeah, that's the part I'll do behind the scenes and actually update you on. So it's pretty much the same exact thing that we're doing with our sequential model we're using in our functional API model. So you're probably wondering why, what's the difference? Why even use a functional API if it's the same exact thing? Well, the difference is this here, if you recall in our note taking. So the question we would ask ourselves is, if we had a model which takes in, let's say, 2 inputs and has 3 outputs, for example. So that's why we would use something like the functional API over the sequential API. The functional API would give us more flexibility and gives us the opportunity to create more complex models. So if we wanted to, we can do things like add 2 inputs and get 3 outputs from our model, which we couldn't do with the sequential API. So that's why we're going over the functional API, just to see how it would be and what we could do to get more complexity to our models. So that's it. That's pretty much what we did this morning. Just more of the same, note taking, code writing, and model fitting. So like I said, the CPU versus the GPU issue is still going to be the same. So what I'll do is I'll go ahead and take notes and I'll go over everything with you during the Python Papi episodes, and then I'll compile behind the scenes, and then we'll go over the compilations on the next day. So yeah, that's where we're at with that. And of course, I will keep you guys posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.